Hey folks, Professor Gray here, ready to talk to you about how to classify data. Once you've gathered your data through a sampling method, there are a number of ways that we classify it in statistics. One way is to classify data by its source. A parameter is a numerical measurement that describes some characteristic of a population. A statistic specifically is a numerical measurement that describes some characteristic of a sample. So parameters describe population, statistics describe samples. I'll identify each of these examples as parameters or statistics. Number 12. There are 435 members of the U.S. House of Representatives. 435 is a numerical measurement, and it's a count of the number of members in the U.S. House. Well, because that number is describing the entire population of U.S. representatives, that is a parameter. Number 13, in a survey of 2,320 adults in the U.S., 5% of respondents said they had a body piercing. The 2,320 describes the number of adults in the U.S. that are involved in this survey. Now, there are more than 2,320 adults in the U.S., but we're talking just about the ones in the survey. Now, that's a sample, so the 2,320 is a statistic. And the 5% is the proportion of those 2,320. So that's also describing the sample, so it's also a statistic. And number 14, in a USA Today online poll, 41% of the 728 internet users that responded said that their college majors prepared them very well for their chosen career. All right, the 41% is describing the proportion of the 728 users that responded. Well, there are more than 728 internet users in the world, but we're only talking about those that responded, so that's a sample. 41% is a statistic, so is the 728 because that is the count or the size of the sample. Both of those are statistics. Another way to classify data is whether it is categorical or quantitative. Some textbooks refer to categorical as qualitative. Categorical data consist of names or labels that do not represent counts or measurements. Their names or labels are categories, thus categorical. For example, political party, hair color, eye color, occupation. Those are all categories. They're names or labels. There are two levels of measurement that are associated with categorical data. The nominal level of data consists of names, labels, or categories only. That's all that you can gather from the data. Data that is nominally measured cannot be ordered, or at least put into any sort of meaningful inherent order. For example, eye color, or yes, no, or undecided. Eye color could be put in order alphabetically, but that order may differ if we're using a different language. There's no inherent order that goes along with eye color. Same thing for yes, no, undecided. The ordinal level of measurement consists of data that can be arranged in some order, ordinal. But the differences between data values has no meaning, or it can't really be mathematically determined. For example, course grades, letter grades, A, B, C, D, and F. Those are categorical data, and the level of measurement is ordinal because they can be put in order. But if I try to subtract A and C, there's no real mathematical way to find that difference. Now, if we were talking about course grades in terms of numerical grades, that would be a different story, but these are just course grades as letter grades. College rankings is another example. You often read publications that rank colleges, well, those rankings have an order, but the difference between those rankings, for example, School 1 and School 3, can't really be determined because the rankings are determined subjectively. So there's no real mathematical difference between them. Plus, the difference between, say, College 1 and College 2 may be very slight. They may be neck and neck. But the difference between College 2 and 3 may be extremely wide. So the data values differences also may not be consistent. We have no way of knowing. Well, as mentioned earlier, data can be called categorical or quantitative. Quantitative data consist of numbers representing counts or measurements. They are quantities. Quantitative is talking about quantities. For example, heights, weights, arm length, shoe size, distance. Those are all the typical mathy things that we think of. They're all quantities, and they're quantitative data, counts or measurements. Rule of thumb, if it's measured, it's quantitative. If there is a unit of measure involved in that particular data, such as inches or feet or pounds, then it's quantitative. It is measured. Be very careful, though. It's not enough to simply look for numbers if you're deciding if data is categorical or quantitative. For example, if I have person 1 and person 2 and person 3 and so on, numbers are involved in that sample. However, that data is categorical. They're just names or labels that have been coded to preserve anonymity. Jersey numbers represent players on a team as another example. The numbers are assigned to different players, but the numbers themselves aren't there because of some mathematical reason. They're there because they're there to have as labels or names. Also, numbers represent colas. You may code colas, like in a taste test. Well, try cola number 1, try cola number 2. Those are numbers, but they are categorical because they're just labels or names. So beware. There are 2 levels of measurement commonly associated with quantitative data. The interval level consists of data that can be arranged in order, and differences between the values can be found mathematically, and those are meaningful. But there's no natural zero starting point at which none of the quantity is present. For example, temperature or years. With temperature, the data can be arranged in order. Temperatures can be put in order. And we can find the difference between 2 temperatures. We just use subtraction. And they're meaningful. But 0 degrees doesn't mean that there's no temperature. 0 is a 0 on a scale. It doesn't mean that there's no heat present either. Years is similar. There's no year 0. We have years like 2015, 2002, 1980. But there is no year 0. So that's the interval level as well. Even if there were a year 0, it would not mean that there were no years present. It's just a 0 on a scale. In the ratio level, just like in the interval level, data can be arranged in order, differences can be found and are meaningful, and there's a natural 0 starting point at which none of the quantity is present. So the biggest difference is that there is a 0, and that 0 means that none of the quantity is there. For example, car lengths. You can put car lengths in order and find differences. And if a car's length is 0, then the car has no length. So it is the ratio level of measurement. Times. Time you spent studying math last night. Well, you can put that data in order. Differences can be found and are meaningful. And 0 time spent studying last night means that you didn't spend any time studying last night. So the 0 means none. Same thing with heights. If the height of my brother is 0, then he has no height. I don't have a brother. Quantitative data values can also be either discrete or continuous. Discrete data consists of values that are individually separate and distinct. For example, the number of trips to the store last week. You could have went 2 times, you could have went 3 times or 4 times, but you couldn't have went 3.145462 times. That's not possible. Those are discrete values. You either went 3 times or 4. You couldn't have went 3 3/4 times. Head counts is another example of discrete value. It's not possible for me to have 25.3 students in my class. I either have 25 or 26. Shoe sizes are also discrete, even though they involve fractions. There are 10.5s and 9.5s and other half sizes of shoes. But they don't make a size 9.67895 size shoe. Those are discrete. I have certain choices that I can choose from. Not any choices available, just certain ones. In continuous data, there are infinitely many possible values along a range. For example, heights. It's possible for someone to be 5.54356927 repeating feet high or feet tall. Distances driven, you might have driven 35.94652 miles today. Calories burned, those can also vary infinitely. There are infinitely many choices that can occur. I may not be able to measure them all, but it can happen. Well, in the next few examples, we'll identify the data in each as categorical or quantitative. We'll identify the level of measurement, and if the data are quantitative, we'll decide if they're discrete or continuous. Number 15 is the political parties of members of Congress. Political parties are categorical. You can't measure or count those. And the level of measurement is nominal. There's no inherent order. So categorical and nominal. Number 16, body temperatures of a sample of mice. Temperature can be measured or counted, so it's quantitative. A temperature of 0 doesn't mean that there is no temperature, so that's the interval level. And since it's quantitative, we'll decide if it's discrete or continuous. Well, there are infinitely many choices along a range for body temperatures of a sample of mice, so that's continuous data. Number 17, numbers of cylinders in a sample of cars. You can count or measure them, so they are quantitative. You can count the number of cylinders. Level of measurement, well, if you have 0 as the number of cylinders, that means you have no cylinders in your car. So that would be ratio level of measurement. And lastly, discrete or continuous. Those are discrete. There are only a certain number of things I can choose from. Even if there were infinitely many of them, no manufacturer makes pi number of cylinders. There are no 2.1545657 repeating cylinders in any cars. So quantitative, ratio, and discrete for number 17. Number 18, favorite month for vacation. Well, months are names or labels, so those are categorical. Level of measurement. Can you put months in order? Well, sure you can. You can put them in order as they fall on the calendar. So that's categorical and ordinal. That concludes how to classify data.